Welcome back to our series of solutions and explanation of competitive coding. Today we are going to solve LeetCode question number 746, min cost climbing stairs. So let us understand the question first. So you are given an integer array cost where cost of I is the cost of ith step on the staircase. So we are given an array of integers cost which holds the costs of ith step at ith position. That is, at 0th position it holds the cost of first stair, and at 1 position it holds the cost of second stair, and so on. Once you pay the cost, you can either climb 1 or 2 steps. So here we are given a choice. Suppose we are on the ith step. Suppose we are on the step 0, and if we pay the cost of step 0, now we have choice. We can't only move 1 step ahead, we have choice to either move 1 or 2 steps ahead. That is, we have given choice at every step, and we can skip each one step at each move. We can skip one step. Okay, so you can either start from step with index 0 or the step with index 1. Again, we have similar kind of choice for starting position. Like, it is not mandatory to start with step 0. We can start with step 1 or 0. We have choice for that. You can not always start from step 0. You have again choice at any stage from starting to end. You have choice to skip one step at a time. Okay, return the minimum cost to reach the top of the floor. So we have to kind of give some kind of optimal solution to reach the top of the floor. Obviously, if we don't skip any steps, we might not get the minimum cost, but that is why we are given the choices that we can skip one step or we cannot skip that, or we don't skip. Let us understand it more graphically. So suppose these are some stairs. We are given some stairs and they have costs like 5, 10, 7, 3, and so on. And so we'll use so could be the maximum cost? Maximum cost could be like 38 if we don't skip any of the stairs, but minimum cost could be like 16 if we skip some of the steps. So we can reduce the cost from 38 to 16, and this is the optimal solution. That is minimum cost solution. So how it could be done? So suppose we are going to do this question with greedy algorithm. So let us discuss a little bit about greedy algorithm. So greedy algorithm always makes the choices that looks best at that moment. That I mean to say is that it makes locally optimal solutions in hope to find the global optimal solution. It doesn't work always, but for many problems it does, and for our problem it works. That is why we are using greedy algorithm. So suppose now let's see, for these two steps, like step 0 and step 1, we don't have any choice. Why don't we have any choice? Because we have to start from the ground, and for ground we don't have to pay anything, but once we come here we have to pay. So if we start from step 0, we didn't pay anything. We are starting just from here. Now to move forward, we have to pay 5. And if we start from step 1, that is step 2, index 1, we have to pay the cost 10. So suppose we are coming, so we can say that we have choice for coming to this step. We can start from ground or we can start from 0. But why would we start from 0? We are paying extra cost of step 0 to come here, but from ground we don't have to pay to come here. So we suppose that we don't have any choices for these two steps. But for this step, we can't come from ground. We have to come from either step 0 or step 1. So from these steps onwards, we have choices. We can either come from step 1 step before, or we can come from 2 steps before. So suppose we didn't modify these two steps, cost of these two steps, but from step number 2 and onwards, we'll modify their cost in order to get the best solution. So how can we modify? Now suppose for this step number 2, where would we come from? We obviously have to calculate the minimum cost. So if we are coming from step number 1, we have to pay 10 to come to this, to reach this step. But if we are coming from step 0 because we have choice to skip one step at every step or every move. So obviously we would like to come from this step. So we are like applying greedy algorithm to locally find the best possible solution. That is, it will be best to come from this step. Obviously we will do this, and yeah, so we'll come from this step and add the cost to this step. That is, we'll modify our array and add the minimum of two costs, the steps before that step, that particular step. So for 7 it will become 5 is because minimum, so 7 plus 5 will become 12. And for this step 3, obviously 10 is less than 12 because we have choices for this step. We can come from step 2 or step 1. So step 1 has minimum cost 10 and step 2 has 12, so we'll obviously choose the step 1 to get the minimum cost at step 3. Similar is the case here. We have 12 and 13, we'll choose 12. And for this we have 13 and 18, we'll choose 13, and 2 it will become 15. And for this step we have 18 and 15, we'll choose 15 because it has lesser cost, and it will modify it to 16. And for this step we have 15 and 16, so we'll choose 15 because it is lesser, and it will become 19. Now for finishing, we have two staircases. Like, we can finish from our last step or the step before the last step because we have choice to skip one step. So in this case we have 16 as minimum because we have choices like 16 and 19, so we would like to finish from step 16 because we can skip this step. So this is more graphical solution. I hope so you understand what I mean to say greedy algorithm is doing. We are modifying our stair in with the choices that minimum, what could be the minimum to reach here, that is what could be the minimum for this stair in order to get the global best solution or the best solution. So let us write up the code so that you can understand it more clearly and we can see that whether it works or not. So we have to start from like step 2. So for I equals 0, 1, 2, and I is less than cost dot length and I plus plus. So each time what we are doing is like we are updating the cost of our original array. Cost of I should be math.min of cost of I minus 1 comma cost of I minus 2. And now we can return from like the last two arrays, last two steps. So return minimum value math.min from in our array cost, and last two would be cost dot length minus 1 and cost dot length minus 2. So I suppose it should work what we have understood in that graphical window. We have written it here as form of code. Now let us run our code to see if it works or not. Yeah, it did work. Let us give them some other values to check if this solution is not only for one case. Let us give them this value. It works for this one too. Now let us submit our code and see the time complexity of code. Or yeah. So it is pretty much faster, and but it uses a lot of memory. I don't know why, because we update the same array, but it seems to use less time, but it is pretty much optimal. 82%, 82.48% faster. So if you do have any question or you have better approach, you can comment down below. And as always, thanks for watching.